All right, let's look at some absolute value inequalities. Absolute value inequalities are equations where instead of an equal sign, I use a inequality sign. Like right here, absolute value of x plus 4 is less than 7. We're going to be using a sign chart to solve this equation right here. But interestingly enough, the first step is to actually solve the equation that is associated with this inequality, and then use those to help us solve the problem. So right here, I have your x plus 4 is less than 7. I actually solved this. The absolute value of x plus 4 is equal to 7. This, as we've seen before, means simply drop the absolute value and create a plus or minus on the other side. So x plus 4 equals plus or minus 7. And then, of course, that's two equations. X plus 4 equals 7. X plus 4 equals negative 7. And we're just subtracting 4 to our heart's content. So x is equals to 3 and x is equals to negative 11. So those are our two key numbers. And what we do with those numbers is we put them in a sign chart, put them on a number line. Well, negative 11 comes before 3. And if you take a number line and you cut it twice, how many pieces do you get? Well, you get 3 pieces. The first piece ranges from negative infinity to negative 11. The second piece is the inner, negative 11 to 3. And then the last piece is from 3 to infinity. What we need to do is we need to test each of these points to see whether or not our inequality sign holds up. Now the easiest number to test is 0. So I'll use a test point of 0. 0 is indeed between negative 11 and 3. So I plug 0 into my equation. 0 plus 4 is 4. The absolute value of 4 is still 4. And I have to ask myself, is 4 less than 7? And the answer is, yes it is. And so you put a little check mark right here to say it works out in this region right here. I can try it in the region over. A number between negative infinity and negative 11, say 12, negative 12. Yeah, 12 is definitely not in there. Negative 12, on the other hand, is inside. If I plug negative 12 in here, I get negative 8. The absolute value of negative 8 is 8. And 8 is clearly not less than 7, so this does not work. Over here, I could take a test point that's greater than 3, say 4. But again, this one will not work out. In fact, these will always alternate. These will always alternate. Doesn't work, works, it doesn't work, or vice versa. And so now I can answer my question. Well, when is x minus 4 less than 7? And the answer is from negative 11 to 3. If you wanted to write that in interval notation, in set Billar notation, you write it as x such that x lies between negative 11 and positive 3. Let's try another one, but this time let's use the greater than symbol. So let's say I have negative 2 times the absolute value of 2x minus 3 is less than or equal to 10. Just like before, I first must isolate the absolute value sign. So I got to divide by negative 2. When I divide by negative 2, the inequality sign will flip. Let's make this a negative 10. So I can make this a positive 5. That's a mistake right there. Yeah, so that would be a 5 right here. And now I am ready to solve this equation. And so again, I don't solve it directly. What instead I do is I solve the equality. Change the greater than sign to an equal sign. And I solve that. Drop the absolute values. So you have 2x minus 3 is equals to plus or minus 5. So 2x minus 3 equals 5, and 2x minus 3 equals negative 5. And I am adding. Get to add 3 to my little heart's content. So 2x is equals to 8, x equals 4, and 2x equals negative 2, so x equals negative 1. And so those are the numbers that go onto my sign chart. Negative 1 and 4. If I cut a number line twice, how many pieces do I get? 1, 2, 3. Negative infinity to negative 1. But now I'm using a square bracket because of the equal sign right here. Negative 1 to 4. And then the last one is from 4 to infinity. Now I gotta test each of these points. Again, 0 happens to be in the middle. It's the easiest number to test. So I take 0 and I plug it in. Well, 0 times 2 is 0. 0 minus 3 is negative 3. The absolute value of negative 3 is 3. Is 3 greater than 5? No, it is not. And that would automatically mean that these two right here are the correct regions. You can go ahead and test them if you want to. That's fine. But this is what's going to happen. And so now that I have this right here, I can go ahead and I can write out my solution. My solution will be from negative infinity to negative 1, union 4 to infinity. If I want to write that in interval notation, that will be x such that x is less than or equal to negative 1, or x is greater than or equal to 4. And that will be my answer in interval notation. Now, other than this right here, there is just one key thing you need to remember. And that is how to solve this problem right here. What do I do if I have absolute value of, say, 2x minus 5 is less than negative 2? What's the answer to this going to be? Well, you might be tempted to set it equal to 0, change the inequality sign to the equal sign, and then create a sign chart and all that goodness. And all that takes you to the answer. There is no need. This question right here is one where you simply need to use your logic to get yourself to your answer. Whenever you take the absolute value of anything, you will get a positive or answer or 0. It's going to be either positive or 0. Well, this number over here is negative. Is a positive number smaller than a negative number? The answer is no. Never. And so the answer to this problem is no solution. It is impossible and thus this question does not make sense. Or, for another way of saying it, there is no answer. On the other hand, if I was to flip the sign, absolute value of 2x minus 5 is greater than 2. This right here, again, you could set it equal to 0 or greater than negative 2. Just switching the sign here. You can set it equal to negative 2, work it out, make a sign chart and all that good stuff, but you don't have to. This is always positive. And this is all going to be negative. A positive number is always greater than a negative number. And so therefore the solution to this right here will be all real numbers. It does not matter what number you plug into this equation, the answer you get will definitely be larger than 2. And so you can write it as negative infinity to infinity if you prefer. Set builder x such that x is an element of the real number system as opposed to that fake number system. But anyways, I digress. Again, don't forget to subscribe.